Okay, so this is the SIA A21, Jan 2013, question 2C on civic heat capacity. So it says here a tank contains 160 kilograms of water at 65 degrees. Calculate the mass of water at 20 degrees that must be added in order that the final temperature of the water in the tank is 45 degrees. Assume that the heat loss to the tank in the situation, we can just ignore it. So, this question always doesn't give us a lot of information, so we're going to have to make some assumptions here. We're going to assume that the water, the tank in which we put the water in, both amounts of water, 160 kilograms and whatever this new mass is, they're being heated by the same appliance for the same amount of time. Because when we say that, remember our energy depends on the power and the time. So they haven't given us a power, they haven't given us a current, a voltage or a time, so we're just going to have to assume the energy is the same. So the energy supplied to the 160 kilograms of water is the energy supplied to the new amount of water. So we can put them equal to each other. So the energy of the 160 kilograms of water is equal to the energy of this new mass. So I'm going to put in my civic heat capacity equation. So it's the mass of the 160 times civic heat capacity of water times the change in temperature for the 160 kilograms. So these little sub things here are just showing that that's the change in temperature for the 160 kilograms, and that's the mass, which I'm going to sub it in a wee minute. So that is equal to the energy of this new one. So it's the mass of the new amount of water. Okay. Then it's also specific heat capacity of water times by that change in temperature of this new water. Okay. So I can put in values. I have 160 times water. Now my change in temperature. So initially this one here was 65 degrees. The final temperature is going to be 45. So this one's being cooled down. So we're going to do 65 take away 45. And that's going to equal to this new mass, again, times the heat capacity value of water. Now we know that this initially, this one's being heated up. And the final is 45 degrees. And this here is 20 degrees. Okay, so when we take these away from each other, it's going to be 25 times capacity times the mass, and that's going to equal to 20 times heat capacity value times 160. Okay, now as you can see, I'm going to have to eventually rearrange this over to get m is equal to, so I'll do that now and show you what I'm going to do with these other unknown values. So my mass is equal to 160 times the heat capacity value of water times 20 divided by 25 times the heat capacity of water. We're not given this, but because the substance, both substances are water, so water for that one and water for this one, they're going to cancel anyway. So even if they did give you numbers, they're going to cancel out. So I'm going to ignore them. So now I'm just going to put into my calculator 160 times 20, which is 3,200 divided by 25. And when I get that, I get my mass of the other amount of water, and that's my answer, 128.